Moving from a blank desktop to a fully functional 3D game engine is a structured, predictable process that absolutely anyone can follow. By the end of this guide, you will have a configured 3D project and a modern input system actively reading your keyboard commands. To follow along, you will need a stable internet connection and at least 20 gigabytes of available storage space on your drive. Completing these initial installation steps perfectly prepares your local computer environment to handle the engine's core development and compilation tools. Start by visiting the official Unity website. Download the Unity Hub launcher and create a free personal account to manage your licenses. Open the hub and navigate to the Installs tab. Click Install Editor and select the most recent version marked LTS, which stands for Long-Term Support. During the module selection, ensure the Microsoft Visual Studio Community box is checked. Neglecting to install the code editor at this stage is the most common reason for script errors later. You should also add the Windows Build Support and Android Build Support modules to ensure you can export your games to multiple platforms. Selecting these specific modules during setup creates the necessary environment for cross-platform publishing and allows the engine to recognize your C# code. Once the editor is installed, click New Project and select the Universal Render as the standard for modern development because it maintains high performance on mobile devices while still supporting high-end PC graphics. When the engine opens, go to Edit, then Preferences. Under External Tools, verify that Visual Studio is selected as your preferred external script editor. In the project window at the bottom, right-click and create a new folder named Scripts to keep your project organized. This wireframe highlights the 5 zones you will use most. The Scene view is your 3D workspace for building, while the Game view shows the camera's perspective during play. The hierarchy on the left lists every object currently in your level. The project panel at the bottom holds your saved files. When you select an object, its specific properties and data appear in the inspector on the right. To test this, right-click in the hierarchy and create a 3D cube, then add a cylinder. Drag them together to create a simple composite shape. You can modify these objects using the transform tools. Use the W key for movement, E to rotate, and R to change their scale. Navigating these 5 panels and using the transform tools is the primary way you will arrange and modify objects within a 3D space. Next, we need to handle player controls. Unity's legacy input system is being phased out, so we will use the modern input system package instead. Open the window menu, go to Package Manager, and search for Input System in the Unity registry. Click Install. To activate the package, go to Edit, Project Settings, and select the Player tab. Under Other Settings, change the Active Input Handling setting to Input System Package New. The editor will ask to restart. Click Yes to finalize the change to the engine's core settings. Once Unity reopens, find the auto-generated Input Actions asset in your project. Select it, and in the inspector, check the box for Generate C# class. Name the class Player Inputs, and click Apply to create the code file. Now inside your Scripts folder, create a new C# script called Input Debugger and open it in your code editor. This diagram shows the logic we are building. At the very top, we add the Using Unity.InputSystem namespace. Then we declare a variable to hold our player inputs data. Inside the awake function, we initialize the variable and use the enable command to start listening for player button presses. Remember, if you do not explicitly initialize and enable the input map in the awake function, your controls will not respond during gameplay. To read movement, we go into the update loop. We write a line that takes the context of our WASD keys and converts it into a vector2 value, which represents x and y coordinates. This script creates a direct link between your physical keyboard and the engine's internal mathematical logic. Save your code and return to the Unity editor. Drag the Input Debugger script onto your 3D shape and press the play button at the top of the screen. While the game is running, press the W, A, S, and D keys on your keyboard. This coordinate grid shows how Unity sees your input. In the Inspector panel, you will see your move variables shift between 0, 1, and -1 as you press different keys. Converting physical keystrokes into numerical data provides the specific vector2 values needed to calculate physics forces and character velocity in the next lesson.